The first two videos in this at-risk XDK series illustrated how easy it is to automate basic tasks in at-risk, especially with the aid of IntelliSense. Specifically, they showed how you can use VBA code to change simulation settings, run a simulation, and display summary statistics and graphs of an at-risk output. The purpose of this video is to show how much more you can accomplish with VBA and the at-risk XDK. It does this by showing the most important items in the at-risk object model. Essentially, almost anything you can do through the at-risk interface, you can also automate with VBA code. This video won't actually step you through the writing of the code, but it will point you in the right direction. Then you can open the XDK example files and study the code they contain, and hopefully adapt this code for your own uses. To highlight the various features of at-risk that you can automate, I will again refer to the Excel file Risk XDK Object Model Diagrams. As the explanation sheet you see here indicates, you can use this file as your cheat sheet as you learn how to program for at-risk. It organizes the information from XDK Help and the Visual Basic Object Browser so that you can quickly see how to perform various tasks such as creating and modifying graphs, or even using the Advanced Sensitivity Analysis tool. Again, remember that before you can do any programming for at-risk, you have to set references in the Visual Basic Editor to Risk XLA and the at-risk Excel object library. Assuming you have done this, let's explore the automation possibilities. The Risk Object Model sheet shows the big picture, a list of the objects in the at-risk object model. It also explains that the reference to Risk XLA is necessary because it provides the basic root object, risk. The typical code sheet is a slight variation of the code you saw in the previous videos. It changes some settings, it runs a simulation, it displays some information about an output, and it creates some at-risk reports. All of these topics, plus more, are covered in more detail in later sheets. The simulation sheet is typical. It shows the basic risk object on the left and how you can use its simulation property to return a risk simulation object. Note the color coding that is used throughout. Specifically, you see on the left that simulation is a read-only property, green, that returns an at-risk object, pink, namely a risk simulation object. From this object, you can start, that is, run a simulation, and you can do a number of other things, as will be discussed shortly. The application settings sheet shows how you can use the application settings property of the risk object to change virtually any of the at-risk application settings. The simulation settings sheet is similar, but now you have to reference a risk simulation object first and then go to its settings property. The results sheet shows how you can access summary statistics of an output or an input. You first reference a simulation and then use its results property to return a collection of results. Then you can use either the getSimulated_input or the getSimulated_output method to return a risk simulated result object and report its summary statistics, including the mean, the standard deviation, percentiles, and a few others. Actually, this will result in an error unless a simulation has already been run. So you can use the exist property of the results collection to check for this. At this point, the terminology might seem confusing, especially if you are new to object models. For example, the results property of a risk simulation object returns a risk sim result collection object, and its getSimulated_Output method returns a risk-simulated_result object. From here, you get the summary statistics. Although this is technically how the object model works, the actual programming is somewhat simpler. For example, to get the mean of an NPV output for a particular simulation, you follow the hierarchy shown in the example code. Risk, simulation, results, getSimulated_Output of NPV for a particular simulation index, dot mean, and this returns the mean. So keep this in mind through the rest of this video and as you do your own programming. The graph sheet indicates how you can access graphs of outputs and/or inputs. Again, you first get to the collection of results. Then you can use one of the 6 graph methods to get the type of graph you want. Once you have a risk graph object, you can use its many properties to fine-tune the graph or send an image of it to a worksheet, the clipboard, or a file. The diagram also shows one of several enumerations, the display format of the graph of the distribution. This diagram does not show all of the details of creating graphs. In particular, it doesn't show how the arguments of the various graph methods enable you to create all of the overlays of inputs or outputs on a graph, including results from multiple simulations. You should view the Risk XDK graph examples to see the possibilities. Just be aware that the programming interface for at-risk graphs is both easy and very powerful. The reports sheet indicates how to generate reports on worksheets. You do this directly from the risk object using the Generate Excel Reports method, followed by the reports you want, separated by plus signs. The available reports are from the enumeration you see here. Here is an example. The model sheet indicates how you can create a list of inputs and/or outputs of your simulation model for documentation purposes. You use the model property of the risk object and follow it with either the getInputFunctions method or the getOutputFunctions method. Each of these returns the number of input or output functions, along with information about these functions. The sample code shows how this works. The fit sheet illustrates how you can use at-risk's fitting or batch fitting tools to fit distributions to data. This is one of the more complex sections of the at-risk object model, with quite a few objects to maneuver through. But by following the arrows and viewing the sample code to the right, you can see that it is fairly straightforward. You first add a fit definition, and then you perform the fit, and you access the results of the fitting process. You can study the fit and batch fit example files to see more exactly how all of this works. The filters sheet shows how you can run a simulation and then add filters to inputs or outputs. Again, the hierarchy tells the story best. You run a simulation and get the results collection, and then you add one or more filters and view the filtered results. The sample code indicates that, as in the at-risk interface, you first do something, like add a filter, and then you apply changes to make them stick. The next 3 sheets indicate how you can implement advanced at-risk analyses with the at-risk XDK. Surprisingly little code is required. Each of these starts with a new analysis method of the risk simulation object. One of these 3. With GoalSeek, you define some parameters and then run the analysis. Here are the parameters, and here I've run the analysis, including the possibility that GoalSeek couldn't find a solution. The advanced sensitivity analysis is slightly more complex because you first have to define the inputs for the analysis before you can run the analysis and report the results. You define the output you want to keep track of. You define various inputs. You specify the reports you want to include, and then you can run the analysis. The stress analysis is similar, where you must again first define the inputs. Then you can run the analysis and report the results. Here is the input. Here is the output to keep track of, and the reports, and then you can run the analysis. Again, all of these advanced analyses require surprisingly little code. Finally, the project sheet shows how you can automate at-risk's project tools. The project property of the root risk object leads to a risk project object. From there, you can import an MPP file. You can create a parameter entry table. You can create a probabilistic Gantt chart. And you can perform several other tasks. Note that the code in this case is controlling the project inside Excel. It is not controlling Microsoft Project directly. Now that you have seen how many aspects of at-risk can be automated with VBA and the at-risk XDK, you can open the example files to learn more about the coding details. Note that there has been no discussion yet about automating Risk Optimizer. Although Risk Optimizer is fully integrated into at-risk, it has its own object model and XDK. You can learn about it in an accompanying video, and you can also consult the Excel file Risk Optimizer XDK Object Model Diagrams and the Risk Optimizer XDK example files.